Aha! So, yeah, so we had the engine and the fuel tank suspended in mid-air, where we want it exactly, left, right, up, down, front to back. So we now need to design some kind of support structure that's actually going to hold it there in real life. So yeah, I could have done this a whole bunch of different ways, and I chose not the hardest way, but the harder than hardest way of doing it. Why? Well, this is kind of at least 70% a sort of design exercise. I do intend to build this boat, but you know, yeah, why not turn it into a bit of a design exercise and make everything complicated? So what I came up with was the first part of that, which any minute now, there you go. Started out looking like this. In fact, it started out looking like this. Ooh, we don't really want that. Started out looking like this orange sketch here, which is essentially the overall shape of what will support the engine at the front here and the fuel tank around here. We have a cutout here for lightning purposes only, and we have a cutout here where we could put a little Velcro strap in to hold the tank down. Yeah, so that bit was fairly simple. And then if we move forward a bit, we obviously need, well, actually, let's move forward to here. So basically what I've done is I've made a cutout at the front where the engine will sit in, and I've put the holes in that line up with the mounting holes on the engine's crankcase. I then did some little bits at the back here. Well, basically the fuel tank's going to slot down inside, yeah, that area there. And yeah, so that should all work. Then what I did, let's have a look, where should we go to? Well, let's go to the end. I think that's a good place to go. So as you can see, I've now added some little structures to the bottom here with some hollow tubes in, which will accept aluminium around tubes, hollow tubes, which will push into there and will push into some kind of similar structure on the bottom. Yeah, like I said, the most complicated way of doing it probably. Yeah, so let's have a little peruse around it. So we've got the two here. Basically, yeah, this is all going to be one thing, and it's going to be 3D printed. Yes, and very long story. I'm building a 3D printer, which will be covered in absolute painstaking detail on this very channel. So this is going to be one of the first items that I 3D print, and well, it probably couldn't really get any more difficult to 3D print because it's, well, yeah. Anyway, we'll get to that later. Point being is that these angles here allow these tubes to point straight down at a point on the deck, and this is a simulation of how far away the deck lid will be. And I know somewhere that there, if it will show it, this line here is where the center of the hole ends. So I need for these points to come down just inside of that, so I can put a structure down here that the other end of the aluminium tubes can go in. Yeah, so they needed to, yeah, basically these angles are decided by the fact that that line needs to end up down here. And the same at the front, and then I've done a sort of front to back one. That support there will stop the engine pulling itself off the boat and rather push the boat forward. So that's that kind of thing. Let's turn these sketches off. Oh my god, it's so slow. Actually, I've got a quicker way of doing this. Let's just close it because we don't need to save it. Discard changes. Right, any minute now. Ah, right, now that Solidworks has woken up from its slumber, so then I created a separate part for the bottom bit. And essentially what I've done here is I've mapped out exactly where these 3 points will be that the aluminium tubes need to meet up with. So very long story short, if I go all the way down to the bottom here, right to the end, you'll see what I came up with, and it's a bit of a beast, really. Yeah, so these are the tubes that the other ends go into, and yeah, some trickeries were that these need to be at the right angle as well at the bottom, and they need to be the right depth and all that kind of stuff. Anyway, that's basically what we ended up with. And I've kind of created some little bridges here, some little channels, which will basically just mean that any water that goes slop into here can run out, and yeah, that's all that's for. We've got some mounting holes here. If I zoom in, ooh, we're going slow again. Okay, so there's some mounting holes. They'll take some hex cap screws, which will then sink down into their flush to mount it to the hull. So let's close that. Let's not make any changes. Discard changes in assembly. And so it seems I am pushing the outer limits of my PC with all this stuff at the moment. But anyway, here we are. We're back where we started. So basically, yeah, then what I did is, let's see, well, first of all, did it the opposite way around, but I won't do it the opposite way around here. We'll do it in actual construction order. So we've got this bit that sort of goes to the bottom, and that screws, like I said, to the deck, and that's there. We'll then have some aluminium tubes, which I can show here, which will basically just push into these holes. This bit will also be 3D printed, hopefully. And then lastly, we've got that top piece where that pushes onto those tubes, and I'll probably just glue it. And yeah, so then the engine bolts into there, obviously, where the holes are, and the tank sort of slots into there, and then we'll put a little Velcro strap around it. Yeah, that's my engine all mounted up and ready to go. So what have we got left to do? Well, I'm going to duct this because it's going to increase the efficiency of the propeller. It's going to provide more thrust for the same amount of, well, whatever you call it, same amount of propeller and speed and stuff. And then we need to deal with, well, we need to steer it, I suppose. So yeah, going to put some steering stuff on there, bit of a throttle linkage. Yeah, that's where we're going next.